Okay, welcome to lecture 3. In this lecture, we are going to talk about precipitation. As you know, precipitation is one of the most important component of hydrological cycle, and it is in fact input to our control volume. And based on its variation in different location, different part of water cycle, we are able to find different solutions for our problems. For example, in places with low precipitation, definitely we should think about kind of irrigation and cultivation that needs low amount of rainwater. And contrary-wise, in places that we have lots of precipitation during the year, those kind of the agricultural production could be suggested to cultivate that they are friendly with the lots of precipitation. In this course, we will talk about physical process of creation of precipitation and some definition. In the next lecture, we will go to the hydrological application of precipitation. Today's agenda includes definition, precipitation types, raindrop size and terminal velocity, precipitation measurements. Maybe you are familiar with some of the part of this lecture, therefore you can accept this as a recall for your knowledge from geography of high school. Okay, you know that any kind of liquid or solid that falls from atmosphere to the ground is called precipitation. Therefore, precipitation have both liquid and solid phases can have. If it is liquid, we give some special name on it. If it is solid, it would have another kind of name. All forms of water that reaches Earth from atmosphere is called precipitation. It is part of atmosphere water and derived from water vapor. Yeah, water vapor is a gas. When it transfers to a shape of liquid or solid, which wants to come down to arrive the ground, it is called precipitation. Okay. There are different kinds of precipitation, and the 5 major ones are shown here: rain, drizzle, snow, hail, and sleet. In the next slides, we will go through the main differences between these 5 types of precipitation. Here you see that rain and drizzle are those of kind of precipitation that are liquid. The snow, hail, and sleet are those precipitation that are solid. This is the main difference, but let's go to more details between rain and drizzle, and then the other other kind of precipitation. Okay, so rain from precipitation, is a form of precipitation that water drop size is between 0.5 millimeter and 6 millimeter. Therefore, the main difference between rain and drizzle, both are liquid, is the diameter of droplets or raindrop. If raindrop is bigger than 0.5 millimeter, it is called, or if water drop is bigger than 0.5 millimeter, it is called rain. If water drop is less than 0.5 millimeter in diameter, it is called drizzle. So we have another entity which is called intensity And based upon the intensity, we categorize rain in three major classes: light rain, moderate rain, and heavy rain. For what is the intensity? Intensity is the amount of rainfall in terms of lengths, for example, millimeter or inch, which rains during 1 hour. Therefore, amount of or height of rainfall that we receive it at 1 hour, it is called rainfall intensity. If the intensity is 1 inch is less than 1 inch or 2.5 millimeter, 2.5 millimeter per hour, it is called light rain. Okay, if the intensity is between 2.5 millimeter per hour to 7.5 millimeter per hour, it is called moderate rain. For the heavy rains, the intensity of rainfall is more than 7.5 millimeter per hour. This is a classification. This is it could be varies in different places, and this is the standard that we have in some countries. Maybe in some countries that receive regular rain, the heavy rain is those that has the intensity of more than 10 millimeters per hour. It depends, but in general, hydrologists accept this classification. Okay, but what is the drizzle? As I told, this is a fine sprinkle of water droplets, very small water drops, less than half millimeter, and intensity is less than 1 millimeter per hour. And it is similar to the fog that you know it, okay? And apart from the size of droplets, there are some ways, some methods that we can distinguish rain and drizzle. And those methods are explained in this video that I'm going to play you. There is no sound background in this video, and just follow the video to see what is the difference between the rain and drizzle. Sorry, the video starts with the construction of rain, how the rain is created first, then it goes to differences. You see, when a drop comes down, it absorbs some other water drops, and gets bigger and bigger. And it is called coalescence. The process is called coalescence, means absorbing other small particles and getting bigger and bigger. And due to the surface tension, water drop always remain a sphere, remain a sphere. Okay, can you guess why the shape has changed from sphere to have a flat at bottom? No.
There can be air.
Because of?
Air.
Because of air resistance, yeah? At down air resistance, push the sphere, and it comes to be flat. Good. And once the diameter of the rain size grows to be more than 4.5 millimeter, okay, see what happened onto the shape. Morph means change the shape. It increasing air resistance at down or lower part. Oh, what's happened? Again, a big drop divided, a big raindrop divided some smaller water droplets, and they continue their traveling downward. You see, this is why we never see big size of droplets. Also, it comes and collects some smaller parts, gets bigger and bigger, but again, any drop, it is divided to several smaller ones, and finally, the maximum size that we see on the air about what? How many millimeters? I told today, 6 millimeters or 7 millimeters, maximum size of diameter. Maybe discusses here this about size. Up to here, again, the main factor to distinguish between rain and drizzle was the size. But from now, you will see the other ways that we can distinguish. Open your hand in the atmosphere. If you feel any rain splash on your hand, therefore this is rain. If you feel, this is rain. If you don't feel, it is drizzle. The other, as you saw, the other way is to look at models. If you look at the models, you know that generally due to the non-uniformities on ground, there are some places that rain collects. If you look, those part grows in shape, grows and grows, but without any splashes, voice of splash, sound of splash, it is drizzle. But if you see splashes, it is called rain. Okay. I think. Okay, so we studied differences between rain and drizzle. Now we are going to talk about solid forms of the precipitation. You know snow very well, and as you know, solid forms we have generally in winter season when we have cold air close to the ground and also cold air in the atmosphere. You see here, based on presence or absence and also thickness as warm air in the atmosphere, we will have different kind of winter precipitation in winter. If let's start from the left side, which is snow. We will talk about generation of ice. These are snowflakes or ice crystals. We will talk next slide. We have a cloud and this is a winter, therefore what we have, solids or snowflakes are falling from the upper atmosphere. If they reach with the shape of flake on the ground without any melting process, because there is no warm air. You see, warm air is this. The red section shows warm air. There is no warm air. Weather is cool enough. No melting process happens. Therefore, any shape of snowflakes with different beautiful shape that they have comes down. It is called snow. However, during this journey from cloud to the earth, if we have a small layer of warm air at the top atmospheric layer, sometimes we have, because a ground could be more cold or cooler than top air. What will happen? Snowflakes will melt, and they will have a shape of rain, or will have a shape of water droplets. But after, when they arrive on the earth, they see very cold air again, which the temperature is definitely below the freezing temperature. What will happen? Water drops will freeze, and they will come to the on the ground. Such a frozen drops is called sleet. Okay, this is the other kind. If the warm air thickness is high, only ground is the temperature on the ground, and so low altitudes. Let's say, for example, 10 meters, up to 10 meters, 5 meters. The temperature is less than freezing point, less than 0. That we have such condition. What will happen? Raindrops just freeze after contacting with the surfaces that have temperature below freezing point. What will happen? Water suddenly will transfer to the transform to ice. It is called freezing rain. Okay. And finally, if the lower part of atmosphere is warm enough, it means temperature is more than 0 degrees. What will happen? Snowflakes will melt, and we will receive the raindrops, and it is called rain, usual rain. Okay, so let's have this figure and what kind of precipitation we had here, for example.
Sir, I have a question, but before question, between the sleet and freezing rain.
Could you talk a bit louder? I don't hear you.
I have a question between sleet and freezing rain. Could you hear me?
Yeah. Your question belongs to this slide.
Can you say sleet is affected by the cold air, and freezing rain is affected by the cold ground surface?
Yeah, just this.
Also, it's similar.
Yeah. No. You know, in freezing rain, the surface and at surface atmosphere, close to the ground, the temperature is below than 0. Thickness, the thickness, you are talking about actually just this part. Both of them, the surface is the temperature of the surface, ground is is less than 0. Yeah. And also the temperature at the atmosphere close to the surface is less than 0.
Less than 0.
Therefore, it creates freezing rain. So with these definitions, what kind of precipitation we had here? The answer is given. Freezing, yeah, freezing rain. You see, the temperature of the body of this airplane and temperature of the ground is less than 0. But the temperature at the atmosphere is not less than 0, maybe very close to the 0. And once rain contacts to the airplane, and the wind direction is also clear. You see, wind direction is also clear. Just once it contacts, it transforms to be solid. It is called freezing rain. Good. So now we talked about different shapes or kinds of precipitation. The question is how precipitation is formed. In general, you know it, and the first session when we talked about hydrologic cycle, I talked about process of vaporization, condensation, getting cold, come down. But here we categorize two main reasons that we have precipitation or precipitation is formed. Atmospheric moisture is necessary. Yeah, these are some necessary, here we have some necessary things. First, precipitation happens when we have enough atmospheric moisture. But it is not sufficient, just moisture, because water vapor is a gas, is a moisture, and sometimes you see in some cities the humidity is too high, but there is no rain. So we can say that atmospheric moisture is necessary but not sufficient for precipitation. And also remember that some other meteorologic factors like wind, temperature, atmospheric pressure, and local landscape can influence precipitation. And can influence precipitation, it means can influence its kind. It could be for example, drizzle, or for example, sleet, and its intensity. Okay, precipitation amount, precipitation type, precipitation intensity can vary based on temperature, wind, and pressure, local landscape. We will discuss more today about those parameters. Vertical transport of air mass is a requirement for precipitation. This is very important. You should see the first one, when we said moisture is necessary, but we said it is insufficient. However, for the case of vertical transport of air mass, it is a requirement. Vertical transform of air mass is nothing than, basically when air gets warm, it gets lighter than cold air, and lighter warm air always moves upward. Yes. If we have it, it means we will have rainfall. Therefore, we know that warm air rises and warm air rises. Therefore, we can expect precipitation. More details will come in next slides. Okay, two processes that can produce precipitations are summarized here. The process one, ice crystal process, is called ice crystal process. The other one is called cold sense process. The second one already presented via that video that you watch now. Yeah, it was cold sense process, cold sense process. But let's go to the ice crystal process. Ice crystal process, aerosols acts in that process. Aerosols acts as freezing nuclei. Ice crystals grow in size and fall to ground. They tend to melt before hitting the ground surface. You know, when the atmospheric temperature is low, cold enough, we have a cold enough, or winter, we are in winter, and clouds have enough moisture to get frozen, and if some nucleus, which we cells aerosols, it could be dust, it could be water, could be any small particle in the atmosphere. It gets frozen and creates a ice crystal, and just after being ice crystal, it gets heavy and starts to come down. It starts to come down, and it is called ice crystal process. The second type of precipitation, which is called cold sense process, is when the condensation happens, and due to condensation, gas, water vapor gets cold and gets liquid, and this liquid comes down, but this is still within the cloud, okay? Comes a bit down within the, another water molecules absorb with the bigger one. The process is called coalescence, gets bigger, and when it's big enough, due to gravity, it comes down. It is called coalescence process. Small cloud droplets increase their size due to contact with other droplets through coalition. Okay, so these are the processes, and the major categories of rainfall. Now, the process that we had precipitation. Here the process are precipitation. The first one mostly creates snow in winter, happens in winter. The second one happens, creates either in winter or summer, creates rainfall. Now here we are going to study three main categories of rainfall events. The first category is connective rainfall. What does it mean? This is when the sun shines on the ground and hits a shallow layer of air close to it. What will happen? What will be happen? Sunshine hits air around you, around the ground. Air gets warm. Warm air rises, yes? It should be explained as the warm air rises. Heated air near the ground expands and absorbs more water moisture, if there is moisture, more water moisture. And now the warm moisture laden air. Now we have a lighter air with high moisture, but it is still lighter than cold air, moves upward, moves up and gets condensed. When it moves up a bit, for example, 500 meters above the ground, the temperature suddenly changes and cold atmospheric condense those warm air. What will be happen? A cloud, the warm get condensed due to lower temperature, thus producing precipitation. Cloud creates and condense, we will have precipitation. This kind of precipitation is called convective rainfall, convective precipitation. Sometimes exchangeably we use rainfall and precipitation, but professionally precipitation includes both rainfall and snow. Convective rainfall spans from light showers to thunderstorms with extremely high intensity. And they have, as you see in these two figures, they cover a small area. Regularly, we have in Antalya this kind of rainfall in different seasons, even in summer, middle of the summer. You remember, for example, a month ago, maybe 2 months ago, when the temperature at the city of Antalya was about 40 degrees, we have suddenly intensive rainfall for 2-3 hours. It was an example of convective air. Why? Because of 40-degree temperature, and we have moisture from Akdeniz Sea. We have enough moisture and we have warm air. Then moisture goes up. But at the upper atmosphere, we have called it, suddenly traps in the condensation, those moisture-laden air, and we will have a shower on the city. And this is why sometimes you see that when you see that we have air in summer generally in one part of the city, but not in the another part. Even so close together, you are driving your car from university to the city center. At Döşemealtı, around Döşemealtı, you see there is rain. But when you receive some place close the city, there is no rain. After 1-2 kilometers, there is again rain. It does not mean that rain stops and restart again. We have those showers at two different points because mostly the convective clouds are thick, not are more thick, not expanded on the big area. Thunderstorms, this is the type of situation where you will have rain on and off through the day. It is also another on and off because clouds rained, no water, moisture, but again again we have warm air, again atmosphere increases, warm air rises, shower, rises, shower. It is called rain on and off through the day with sunshine between them, because when there is sunshine, again warmer air we will have. And it seems like the weather cannot make its mind up. Weather cannot make its mind up. It means that cannot decide what should be, sunny or rainy. Example is summer thunderstorm. Okay, this is the first category of rainfall, convective rainfall. The other kind of rainfall is called frontal or cyclonic rain. You have heard also this cyclonic. We have a cyclone in the meteorology reports. You have maybe heard a big cyclone comes close to the, for example, eastern Turkey. Therefore, we will have 2 or 3 days rain at the eastern part of the country, blah, blah, blah. You see, I'm talking about big areas. This is called cyclonic rain. The uneven heating and the reason are discussed here. Let's read together. The uneven heating of the Earth's surface by the sun results high and low pressure regions, and air masses move from high pressure, cold and dry air regions to low pressure, warm, wet air regions. If warm air replaces cold air, the front is called a warm front. If cold air displaces warm air, it is called cold front. You know, all the origin comes due to the shape of the Earth. You see, the latitudes close to the equator are close to sun, they are generally warm area, yeah? Warm. What will be happen? Warm area, therefore they get warm, and a massive amount of warm air will have here. Therefore, it is, however, at the Arctic, for example, or high latitudes, we have cold air. We have warm air in some part, we have cold air in another part of the atmosphere. And there is a circulation between warm air and cold air. Once, due to this circulation, we will have connection of warm air to massive warm air will replace cold air, or sometimes cold air will replace warm air. We will have, due to this displacement, we will have rising warm air, and therefore we will have rainfall. Let's see in this figure. For example, this is a plan, a plan of Earth. You are looking from up to down, okay? And you see that cold air from this is a cold air zone, from the high latitudes get closer to the middle latitudes, okay? And due to motion, one of them should replace the other one. And here, when we have boundary or border between cold and warm air, it is called front, yeah, front. Front means boundary, border. And depends on which displace the other, we will have cold front or warm front. Here you will see an example from not written here, when those two large areas warm doesn't, but we can guess this is cold air or warm air. You see cold air comes below the warm air, and warm air, it means that motion is from here to here. Let me show you in that way. Okay, cold air push forward warm air, and warm or cold air goes to below the warm air, and warmer air should rise up, yeah? When we have rise up, we will have cloud, and then we will have a rainfall at this area, yeah? Because I have cloud. Because cold air displaced warm air, it is called cold front. Okay. Yeah. Therefore, we will have rainfall here. It is called cold front. Now let's these two other example for cold front and warm front. Look at this one. We have cold. This is cold front, like a previous example. I talked about it. However, here you see that warm air moves toward cold air and pushes cold air to go away from this part. At the same time, because warm air sees cold air, it has to go up. It is lighter. When it goes up, we have enough reason to have precipitation, because warm and moisture-laden air rises. Therefore, precipitation will have. And at these areas, which is generally a large area, entire city, entire province, we will see, we will have rainfall. This is the second type of precipitation or rainfall. It is called cyclonic rainfall or frontal rainfall. And the third and the last categories of rainfall is called relief or organic orographic precipitation, orographic rain, which is as a result of landscape. We told that when warm air rises or when moisturized warm air rises, we will have rainfall. Look here, for example, a sea close a sea or an ocean, we have a mountainous area. Okay, we have a mountainous area, and we assume that wind blows from sea to the land. From sea to the land, what will be happen? Above the sea, the air is moisturized because of the evaporation process. Air masses above the sea, it has enough moisture, and due to the wind, it comes to the land. The moisturized air comes to the land, but suddenly those air mass see a mountain in front of it. A mountain. What will be happen? It should goes up. Yeah, it should goes up in order to continue. The wind wants to continue. Okay, it's an obstacle. It goes up. When it goes up, what will be happen? In the higher atmosphere, it will experience cold atmosphere, and then clouds will be created, and we will have rainfall. It is called, this kind of rainfall is called relief or orographic rainfall. Very common in the cities close to the seas, and also the cities that has mountains close to the coastline. Like Black Sea region, I will show some examples there. Black Sea region, you have a Black Sea, and suddenly we have a huge mountains close to Black Sea. Therefore, we will have two separated climate at two different sides of the mountain. One side is called windward. You see windward, the side which is close the sea or looks to the sea, the side of mountain that look always will be green, because the warm air goes up in that side and we have a rainfall. Therefore, the air which moves to the other side of mountain, there is no moisture, and therefore there is no cloud, and this part is called rain shadow side or leeward. Relief precipitation occurs when a moisture-rich air mass is forced upward by a landform barrier, like mountain. Landform usually responsible is mountain. Precipitation usually falls on the windward side or side of ascent. Windward, this side. Leeward side or side of descent is usually moisture poor. These areas are called rain shadows. Okay, this side is called rain shadows. Example, as I told, is Black Sea region. Black Sea region. This is topography map of Black Sea region. Look, here close to the Black Sea is green, but far from the Black Sea is gray, not green. The reason is orographic rainfall, because when wind brings the moisture-rich air to the country, to the land, here you see a big mountains. I don't know the names, but a big mountains are in this part. Okay, this is the line of a mountain. Okay, and we have rain shadow area here. For example, you see Erzurum province is gray, but Rize province is green, because what comes moisturized air creates orographic rainfall here, and this side is rain shadow, there is no precipitation. And if this is, I get this concept from this figure. Is it true or not? To check this, we can look at the precipitation records at different precipitation gauges that we have in the country. And I did it. Let's check again those conditions. Look. You see, this is the side of mountain that looks at the sea, Black Sea. This is rain shadow side of those same mountains. This is the same mountain, but looks at the Erzurum province, rain shadow side. And this is why here is green, and you see the green in the map. Okay, do you want to really understand the orographic rainfall, how much orographic rainfall, how much difference we have between the total amount of rainfall of Rize province and Erzurum, how much difference we have? Yeah, I would like to explain it. And what is the main reason for such difference that we will see in the next slide is just these mountains. Okay, let's go to the relevant data. This data was taken from the Meteorology Organization of Turkey, and you see these are monthly data including temperature and total monthly rainfall. Okay, total monthly rainfall that I'm interested in. And the data belongs to, the data is what? The data is the average of 20 years from 1981 to 2010. For those 20 years, each month I had this value of, I had this value of total precipitation. What does it mean? It means that, for example, in the month of Haziran, Rize province received 138.7 millimeter of rainfall in average at those 20 years. Maybe in 1981 it could be 140, at 1982 135, 100 at another year 150, 60, so 40, 20. Anyway, at these 20 years, if you add all together, then divided by 20, the value is 100 for that month. And if you add all together, you can find the average annual or mean annual rainfall at Rize province. And you see that at Rize province, the mean annual rainfall is 226 centimeter, about 200 because it is in millimeter, to more than 200 centimeter, or let's say 2200 centimeter. Sorry, 220 centimeter. Okay, let's memorize it. What is the average precipitation in Rize province? 220 centimeter, okay, per year. 220 centimeter per year. Am I right? Yeah. So let's go to the same value of Erzurum. Now my province is Erzurum. and these are monthly values, and the sum of annual is just 40 centimeter. 40 centimeter, compare it with 220 centimeter. Less than one fifth. Less than one fifth. In other words, Rize province receives 5 times more rainfall than Erzurum. Why? Because of orographic effect. The main difference here is orographic effect that sets these differences between the precipitation. Okay, now I talked for an hour. I will give you 15 minutes break, then come back to continue with the calculations of terminal velocity for a raindrop. Any question?
Sir, I have a question.
Go ahead.
Could you?
Yes.
When you explain orographic rain, you say to us and you gave examples of Black Sea, like Erzurum, Rize. But when you explain orographic rain, I thought White Sea. For example, Adana, Antalya, Mersin, because of Toros Mountain.
Yeah, you are thinking there is such a pattern or not? Okay. To answer your question, if you are, we should check the both topography and rainfall data. I didn't check it, but the important point is that the mountains should close to the sea.
Yes, I know. But in Black Sea, mountain has very close. But in Antalya, Adana, and Mersin has big mountain close, but not very close.
Okay, this is therefore, and this is, you are comparing these 3 provinces together or with provinces that are the other side of Taurus Mountains. Don't compare together, okay? Compare the provinces which are at the other side of the mountain.
Okay, understood. Thank you.
This is one point. The other point, therefore, one point is distance of mountain from the sea. The other point is wind direction. If wind direction is from sea to the city, therefore moisture A comes to the city, comes to the mountain. If in general wind direction is from city to the sea, you cannot see such a distinguishable differences in the rainfall pattern of provinces at rain shadow side and windward side of the mountain.
Now it's clear. Thank you,
Okay,
sir.
good. Thank you for your question and also for your attention. Any other question? No, so let's meet each other at 2:15. See you for now.